Hi! So a couple weeks ago, I made this video where I, as a pretty established competitive programmer, with basically zero experience in interview stuff, took on a bunch of FANG questions to see how it would go. And that went pretty well. In fact, maybe a bit too well. I would even say those FANG questions, despite being hard difficulty, went down pretty easily. So today, I've decided to step it up a bit. Instead of taking on some hard FANG questions from LeetCode, I've decided to try the hardest questions ever on LeetCode. Asterisk, because I know that the lowest solve rate doesn't necessarily mean the hardest questions, but top competitive programmer versus LeetCode's questions with the lowest portion of accepted submissions to total submissions doesn't exactly have the same charm to it, does it? I'm sorry, the clickbait is just too good. You can argue that maybe I should do lowest solve count instead, but even that's up for debates and some questions are just viewed a lot more often. So yeah, we're doing lowest solve rate, and the goal is to find out how good is competitive programming really? Is it enough to dominate even the hardest questions that LeetCode has to offer? Or will these questions finally be enough to stump me? And what can we learn from these questions? What's the common factor between these that makes them have such a low solve rate? And you can find out the answers to all of these questions, like, right now. And now for a jump cut. So here's the format. It's pretty similar to last time. I'll do 3 questions picked from the list of lowest solve rates, so by default they'll be hard difficulty. We'll just do them, and I'll show the whole process from start to finish, though I'll cut out the parts where I'm just staring at a wall and saying nothing so the video isn't like 2 hours long. And at the end of each one, I'll do a recap of how the question went in terms of time taken and other interview-specific stuff like other more efficient solutions that I may have missed, as well as going over like failed submissions and the mistakes I made. There are timestamps in the descriptions, you can jump around to these if you want. And one more thing, feel free to try each question yourself, but I'm not going to go over my own solutions here, similar to the last video, because it's not really relevant to the point of the video. But if this video gets me over 2,500 new subscribers, yeah, I'm raising the expectations, then I'll post a separate video that goes over my solutions and thought process to all of these questions as a bonus. I did that for last time too. So hit that button. That is all. For real now, let's start. Alright, so we're here with the hardest question on LeetCode with a 14.2% acceptance rate, strong password checker. And yeah, I have no idea what I'm in for. Let's get started. So, okay. Password is considered strong, has at least 6 and at most 20, contains at least 1 lowercase letter, 1 uppercase letter, 1 digit. It does not contain 3 repeating characters in a row. Okay. And you want to edit distance to make passwords strong. Okay. Password length up to 50, so alright, that seems fun. It happens to be question 422, which is pretty cool. Okay, so how do we start this? If we, so if we have 20 characters already, then what we could do is, okay, so we can break the string into groups, I guess. Oh god, okay. So if we have too few characters, then we have at most 5. So if all of them are the same, then we have to break it up into... Okay, ultimately I think breaking it up into groups is the right move, because then we can split those groups. So to handle a group, we can remove a... Okay, these samples suck. Letters, digits, dot, or exclamation mark. Why dot and exclamation mark? Okay, that's fun. Alright, I'm honestly not sure how to start this. This seems very, very fun. So, we want to... Okay, we have too few characters, right? So we need to insert. So we break the string up into groups. If any group is size more than 3, we insert a character. Okay, this is very annoying because, yeah, this is very annoying. Okay, so 20 has to be like relevant. Like maybe we can do like some stuff to handle that. Because there's like, the string can be represented as like groups of characters and then a boolean for each lowercase, uppercase, or digit. And those are interchangeable and it doesn't really matter which, so it's really just the number of the number of different types of things we have. The number of lowercase, the number, or it's like the number of, yeah, different types of things we have. We can represent it in groups. And we can, okay. We can also, so if we have too few characters, we can brute force kind of. Yeah, we should be able to brute force. Because we can just like, we can do like a binary string where it's like equal to the next character or not. And then that way, they're at most 3 times 2 to the 19th representations, which is reasonable. Or we could not do that. What else could we do? So we could, so if we have too few characters, right? So we need to insert. So there can be at most one problematic group, which is good. Because that means, maybe we don't need to brute force, maybe we can do this systematically. So there can be at most one problematic group, which means that we'll insert characters to, we'll insert characters to make that happen. I'm glad they don't make us output the string, because that would suck so much. But okay, so there are 3 cases. Password.length is too short, just right, or too long. So if password, actually let's break it into groups first. So vector int groups. This is C++, yep. Okay, int L equals 0. I equals n, I plus plus. If si not equal to sl, g dot push back I minus l. Push back I minus l. L is equal to I. So that represents the start of the group. So we're breaking into groups for okay, so this should, we'll just test that this works. Replace that, yeah. Okay, I just want to see the output. Come on, LeetCode. Actually, this is my fault, but yeah. std out 1. Yeah, okay. std out should be 1. Yeah, alright, come on. This is getting dumber and dumber. So yeah, it should be 1, 1, 1, 1, 1, 2. Okay, perfect. Let's just test this. Make sure it gets that right. 2, 3, 2 it should be. Perfect, okay. So now what we need to do is casework. If s.length is less than or equal to 5, so we'll check lower, check upper, if okay, so now while we should do n. So, okay, so if, so for int x g, if x is greater than or equal to 3, x minus equals 2, count plus plus, n plus plus, found is equal to 1. Also, total plus plus. If not found, break. Then, so if n is less than 6, all right, we can just handle this here. If not found, count plus plus, n plus plus, toe plus plus. So the only difference is x minus equal 2. Yeah. Okay, so that should get that right. So it should get those two right. Yeah, okay. All right, so we need to handle the two other cases. Else, if 6 is less than or equal to n, and n is less than or equal to 20, while count is less than 3, int max equals, wait, this is a thing, right? Yeah. So that's a thing. Can parser be empty? No. Okay. So while count is less than 3, or max element g dot begin, g dot end is greater than or equal to 3. So what we need to do is replace. So bool found is equal to 0 for int xg. If x is greater than or equal to 3, then we can reduce it by 3 here. So x minus equals 3. And this is technically a bit incorrect, because if we have 3 characters, we don't reduce the group size to 0, we reduce it to 2, but that doesn't really matter. All that matters is if it's greater than or equal to 3. So x minus equals 3. Also, we can just return toad at the end here. Toad plus plus. Count plus plus. Don't need to increment n. Found is equal to 1. So if not found, do a similar thing. So count plus plus, because we replace with a new character, n plus plus, and no, not n plus plus, toe plus plus, and that should be it. Okay, this should not affect that. So we'll add in another test case soon. So let's try a b, 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 a b, b, b. Make sure it gets all of those. Sweet. Okay. That should be enough. So else. Now, this is the most annoying part. It is very annoying, it is not fun, but we need to do it anyway, so we're going to do it. Okay, so we need to reduce it to 20. We need to reduce it to 20 and then do the same code here. Why is there a gap? Okay, so we can just copy paste this in the end. But what we need to do is delete from where, yeah, okay. So while n is greater than 20, for int x g, if x is greater than or equal to 3 and x mod 3 is equal to 0 and n is greater than 20, what we need to do is delete a character from that group. So to++, do not increment count++. Let's see. Yeah, so we need to increment x, we need to increment tote. Okay. Then what we need to do is do the same thing here, except this is 1. Well, n is greater than 20 and found equals 0. X is greater than or equal to 3, yes. And then the exact same thing, except now it's 2. And there is a better way to do this, and I don't care. We can do this with a loop. Actually, you might as well do that. Yeah, sure. Makes it a bit cleaner. And this might seem like a bit of black magic, but it will work. Yeah. So while n is greater than 20, tote plus equals n minus 20. And now we do this. Okay, so let's do some testing. I'm going to get rid of all of these because we already tested that. Get rid of the samples. So, A. Okay. See if that works. Wrong answer. Okay. Why are you 23? Okay, that is a good test. And minus, that's why. $17, okay. That is worth noting. For int x g cf x. Cool, let's test that. What is happening with these groups? Oh, that's why. Ops. Minus equals ops. Yeah, there we go. That should fix something. 4677. Alright, come on. Nice, okay. Alright. So I think sure, we'll try that. Alright, let's see. test that too. 8. Yep. All right. Perfect. So first case, 1 is less than 6. For each thing that's greater, if that, insert there. And there can be only one of those, so we don't really have to worry about how that works. We can just do it. And for here, we delete a character from it's count plus plus. Yeah. That should matter. Yep, that should matter. Because otherwise, this would fail here. Yep. So while n is less than 6 or count is less than 3, there we go. So while count is less than 3 or we have a problem element. Interesting. That works by accident. You can add that there too, though. Yeah. Should be fine either way. It'll work by accident. So that's fine, that's fine. So while count is less than 3, and this is true, do that. Otherwise, try and reduce the remainders. Min r plus 1 and minus 20. Yep. And then do the exact same code. Okay. Seems legit to me. Nice. All right. Very slow, but that's fine. I think we're good. Okay, so this one ended up kind of mixed. I was pretty slow on it, but that's also because I was kind of taking my time and being extra careful to cover every possible case, because I knew that if I missed the case, it would be pretty hard to check everything and it would just be extremely annoying. So my solve time ended up on the longer side, but I do think it was worth it because I also got the question first try. I would say that this question was quite annoying, but it was also fair. There was a relatively clean way to handle all the cases, and I did end up finding it, as far as I know. And it's hard to tell whether being careful was the right move because it did again cost me a lot of time, but it would have probably cost me even more time if I was trigger happy and got a bunch of wrong answers. Honestly, I don't know. I'm not really sure how I did on time. I guess considering that it took the average person 7 tries, even 27 minutes wasn't that bad. And my solution was O of n squared or something. I think there are a lot of ways that can be easily optimized, probably even down to O of n, but I was honestly here just being extra careful and not really concerning myself with time complexity. So maybe it wasn't the best complexity, but m was only up to 50 anyway, so it's not such a big deal. The runtime was 5 milliseconds. And yeah, that's all. On to the next question. Alright, here we have booking concert tickets in groups with a 15.0% solve rate. And looking at this statement, oh my god, this looks horrible. So yeah, let's do this. We may be here for a while. Okay, so concert hall is n rows, 1 to n plus 1, each with m seats. Okay, ticketing system for group of k spectators can sit together in a row if every member of a group of k spectators can get a seat. Okay, so m is constant. Oh boy. Okay, they will book seats only if each member of their group can get a seat with row number less than or equal to max row. What? Oh my god. In case there are multiple rows to choose from. So this is online, so we don't get to prepare ahead of time. Oh, okay. Oh, okay. So it's n 5 times 10 to the 4th, m is up to 10 to the 9th. Okay. Max row is up to n minus, yeah, okay. Alright, so Do we need a segment tree? That's the state of mind I'm in. I'm guessing no, because, well, we might. This might suck. This might suck very much. Yeah. So okay, let's just think. So, scatter is easy. We just do it. Scatter is easy, we just do it. Yeah. We can keep a linked list of the empty rows for scatter. So the hard part is gather, I guess. Can we do it in log time? You basically just need... K is not... Yeah. Okay, so for scatter, we can maintain a linked list of the rows that are not fully booked. And that way we can do scatter in O of n amortized. Yeah, the problem is gather. And allocating means the seats are booked, yeah. So max row doesn't really matter. What we just need to do is find a way to... We need these small... So we keep track of the number of... Let's keep track of the number of seats in each row. And... So both gather and scatter do book seats. Okay. So we need to find out the lowest row. Okay, I mean we can do this with segment tree, but I don't really want to do that. There's gotta be some better way to do this. We need to find the lowest possible row. Can't use a sparse table. We can do segment tree descent. Like, I don't want to do that. Is there a way to not do that? Because we can get an arbitrary array here, which is the problem. I really don't want to do a segment tree. Like, I haven't implemented that in so long. I feel like it's not fair to copy paste one in, because I have a segment tree template, but this is like an interview scenario, so I probably would have to implement it on my own. Is there any caveat here? Is there anything that makes life easier? And I don't think there is. Well, wait, maybe there's some amortization here? Because to get an arbitrary array, scatter will... So say we just have gathers. Scatters don't really do anything. So let's say we just have gathers, right? So if we have some value, one arbitrary array. Do we just need a segment tree? Is that what we're doing here? I feel like it is. I feel like we're just doing a segment tree. I really don't want to do a segment tree, but okay. Because, like, how else would we do this? If we need the smallest thing, the smallest row that is less than or greater than or equal to R or K dynamically. How do we not use a segment tree here? So we can remove so if we do gather, right? If we have something of this size, is every gather query like the thing is it always decreases. It always decreases. So we can I'm really thinking to try and avoid a segment tree, but it just seems like we need it. Like I don't see anything else. It might just be why the solve rate is so low as well, because, yeah. Because it always decreases, so we could use that somehow, right? But how would we use that? So essentially, we have a thing. We do have a thing. That is true. We have a thing. Screw it. We'll do a segment tree. Alright, fine. tree I is equal to min tree I b. If p is less than equal to m, upt pv 2 times I plus 1 TLM. Okay, sure. Int get int k. If TL is equal to TR, return TL. How do we do this? If, all right, so what we need to do is if tree 2 times I plus 1 is greater than or equal to k, return get k 2 times I plus 1. TLM. Else if tree 2 times I plus 2 is greater than or equal to k, else return -1. Int pos equal to get k 0 0 and -1. If pos equal to -1, return vector int, else so pos rem pos m minus, wait, what? Yeah, m minus rem pos. Pause, rem pause. This will be a mess to test, for sure. Yeah, so while true k is greater than 0, int pos equals get 1 0 0 and -1. If pos equal to -1, return false, otherwise k minus equals rem pos. Rem pos minus equals r, k minus equals r, upt mini. Okay, so this will work, probably work on the first try, right? Yeah, totally. Bool void Yeah. This will totally work on the first try. Why would it not work on the first try? Okay, it actually did. All right, but I'm not going to stop there. Okay. So let's see. So we'll do book my show, gather, so 1, 3, 5, 5, 0, 3, 2. Okay. I do like how it computes the answer for you. So that's nice. Why do you get 2? Pause, get k, 0. What? Tree 2 times I plus 1 is greater than or equal to k. Oh, I'm dumb. Okay. This is range max query. I'm so dumb. Yep, okay. Okay. Let's test some more. Is it like it parses these arrays? Can you like do some ace here? Be kind of funny. Should get 2, 0. Okay. Let's test scatter somewhere. Okay, so let's see. So we want something like 3, 5, sure. Gather 1, let's do like 3. Scatter 5. Gather should be, for example, 3, 1. Scatter 1, 1. 2, 1, 2. That should work. Okay. 3, 5, yeah. 3, 2, 5, 2, 3, 1. Yep. 1, 1. Gather 2. Alright, let's see. So, update. TL equals TR, TR equals V. Update the left, otherwise update the right, then update this. Update mini, sure. So if the left is greater than or equal to k, do that. Otherwise, if the right is greater than or equal to k, do that. Otherwise, yeah. So book my show, init, yep. So int pause equals get. If pause that, yep. Otherwise, m minus rem pause is correct. Rem pause minus equals k, update mini, perfect. And now while k is greater than 0, get the first thing with 0, pause equal -1, or pause greater than max row, yep. Otherwise, remove what we can. Update, return true. Okay. See if it works, I guess. Wrong answer. Okay. Why? Guess we can look at the test. I guess they're giving that. So book my show 37 scatter 90 should be false. Gather 22. 22. What do you mean? Wait. Oh shoot. Okay. All right. Ups. Okay, so the problem is I'm scattering. Oops, stop, push, back. So this should be pause, R. 4. I see the issue. Yep. Update mini. X dot first. Rem x dot first plus equals x dot second. Okay, so it's, yeah. Okay, so do not scatter. Yeah, okay. So updates that push back. Pause and R. Yep, so rem. Okay, let's see. Alright. That bug is fixed. Pretty sure I'm not gathering if it's not valid. So we'll see if that works. Wrong answer again. Wait, what? Oh, this is like the simplest thing. Huh? How? Why would that happen? That's like the simplest input. Ah. If that is dumb. That is a dumb bug. If tree I is greater than or equal to k, return TL, return -1. Any other things hiding in the shadows? We should check the code again. So update, right? So update is standard second tree update. It's fine. Now this, I forgot. Okay. So that's like the only case. Otherwise, it's greater than or equal to 2, and therefore it will check all of these. Yeah. So now we're undoing the things. Okay. All right. I'm not happy with this, but it's taking longer. Time limit exceeded. Really? All right, this is a fun problem. We're having fun with this one. What is the time limit? Will it tell me the time limit? Or will it not? Oh, I see the issue. Okay. Right. Okay. Yep, so broke my own assumption, and therefore, yep. Okay. I see now why the average is so bad. So how do I do this quickly? How do I quickly fix this? I need a Fenwick tree, I guess. Sure. $50,000. int p int v. Yeah. This is fun. So for n equals p, I minus equal I negative I is greater than 0. Update goes down, sum goes up. Bit I minus equals v. Wait, does something... I don't know. I don't actually remember. Does update go down or up? So we can try both. It's pretty dumb. I don't write fragment trees often, by the way. Sum is equal to 0 for int I equals p. That makes sense. The one index there. Sum plus equals bit I. Okay, so now we don't need to do this anymore. So it's wait, let's be consistent. So get bit max row minus 1. No, it should be max row. If total is less than k, return false. Minus k. V minus RMP. Right? Yeah, so this should be, yep. Okay, I'm not expecting it to compile. Yeah. Oh, I know how to write for loops. Cool. Why? What changed? Okay. So V minus RMP, right? Oh. That is why. We do need that, because we're pushing back. Print tote. See what's happening there. Oh. Is that why? Because we're doing this? It shouldn't actually... Okay. 14 is a bit wrong. Let's do that. Why are you -6? Wait, why did I do minus equals? What? Int d equals v minus rem p. V should be smaller. Now I'm confused. But okay. Okay, 6. Yeah. Okay, this is such a mess. But it should work now? It should work now. Crossing fingers. Okay, yeah, that was a very big mess, but... Whew, okay. Well, that's done, at least. Okay, so that was not smooth, not in the slightest. The 41-minute time and 3 failed submissions should indicate that. So here's a brief overview of what happened, what went wrong. The first wrong answer was because I was doing partial scatters. Because I was updating before seeing if the scatter was fully possible, like updating the list, I was booking some fraction of the people even if the scatter was invalid, which shouldn't have happened because the question says to not book people at all if it's invalid. And I figured that out pretty quickly from the test, but I had also made another mistake, which was that I needed to return -1 from the segment tree query if n was 1, but I didn't because I missed that edge case. But, I mean, I don't know. In general, that's okay. Edge cases happen, though I probably should have tested n equals 1 beforehand. That's a pretty common thing to mess up. Then, after that, the time limit exceeded happened because previously I had made an assumption that the scatter code was going to take amortized n log n over all queries, since if it's scattered across multiple rows, then all the rows except the last one were guaranteed to be filled, and therefore removed from the rest of the queries. But since I had changed my scatter code to fix the first bug, that assumption was no longer true, and I can end up processing basically all of the rows in a single query, but having the scatter still be invalid, meaning none of the rows would be changed, and I just wasted O of n log n on that query. So overall, it would take O of qn log n, which is horrible and would obviously TLE. So to fix that, I had to use a range sum query to fix the TLE and figure out if the scatter was valid beforehand efficiently, so that my assumption would be true again. And that finally worked. So yeah, it was not a good time, not a good question, not a good performance at all. And it probably would have been a lot worse if LeetCode didn't show me the failed tests, so maybe the honest thing to do would be to not look at the tests. But also in a real-world scenario, you'll probably know the test I failed on, so whatever. And I also wasted a lot of time in the beginning trying to think of a way to avoid using a segment tree, but I don't know if it's possible without a segment tree anyway, so I just ended up using one in the end. And ultimately, I ended up with O of n log n plus q log n, which I think is definitely optimal, especially if you're forced to use a segment tree and just looking at the discussion section. And my code could be constant optimized a bit more, but I don't really care. It's fine as it is. It doesn't really matter. Anyway, on to the next one. Okay, so here we have fancy sequence. Cool. And yeah, this has a 15.7% accept rate. Okay, and we have 4 things to do. Okay, so initialize the object with an empty sequence. Oh my god, that's a lot of things. Okay. So val inc m 100 modulo. Good. So append to the end, add all. So increment, mult all, multiply, get index. Do we need a segment tree? Is that what we're doing here? 10 to the 5th calls. Okay, yeah. Do we need... We're really doing another segment tree problem, like, right after? You serious? Because that would suck. So add all. Right. So applying an update applies it to the prefix. We can store a segment tree that stores a function mx plus b. That is fine. I feel like we might just have to. Like, do we just have to do a segment tree here? Is that where we're going? We have range update point query. But like also maybe not. Because to a certain point, if we can get the inverse of each function, then we can do it with just like a vector and binary search. If we can get the inverse of each function, right? We don't necessarily have to do a segment tree. If we can get the inverse of each function, then how do I get the inverse of each function? So if we have like over m, right? So if we could do that, then if we plug mx plus b into that, then yeah. Okay, sure. I think we can do that. So long m b, m is equal to 1, b is equal to 0, and then vector int invs. So ims.push back mb. Long vowels. Okay, so alright, so inc mod b is equal to b plus inc time mod m is equal to m, what is this, up to 10 to the 100, okay, m times m is equal to m times mv mod b is equal to b times mv mod. Okay. Equals vowels idx. If idx is greater than or equal to index is greater than or equal to vowels dot size, turn -1. Okay, so long mpow base. So if e and 1 r is equal to r times c mod, r is equal to r times c mod, c used to my macros. Forgive me. Fancy. Get index. Why an array? That's a problem. Why does that happen? Why would I do and? Why? What? Why? That's so dumb. Why? What the hell is that? Okay, we're getting that right. Good. So v is equal to v minus ims idx dot second plus mod v is equal to v times ims idx dot first mod v is equal to v times m plus b mod return v. Second first. Okay. All right. So I guess we can just try it. I mean, why not? Like, this seems like it works. I don't see why this would fail. Nice. Alright, that was quick. Okay, this one was very smooth. Honestly, I'm not sure where the low solve rate came from. Could be the modular arithmetic, or maybe a lot of people wrote segment tree stuff, but for me it wasn't bad at all. And unlike the last question, this time it was worth taking the time to think about how to avoid a segment tree, because there was a very clean solution hiding just around the corner. And I'm sure my complexity is optimal. It's O of 1 per insert and O of log per query, and you can shift the log around to make it O of log per insert and O of 1 per query, but it doesn't really matter. Yeah, so this was smooth. On to the conclusion. So my performance here in these 3 questions was just all over the place. Question 3 was great, question 1 was slow, and question 2 was horrible. And it's hard to tell what was really common among these 3 questions. I guess 1 and 2 had complicated solutions with a lot of places to go wrong, and maybe 3 had that trait with its modular arithmetic, but other than that, it's really just hard to tell. But I would say in general it's better to be careful, because the more careful you are, the more confident you can be in many areas of your code, and the more easily you can rule stuff out while debugging. In terms of myself, I did finish each one in under 45 minutes, and I did fix each bug pretty quick because of that confidence, so I guess in an interview it could be called a success. And I wasn't actually stumped by any of the questions either, because pretty much all of my downtime for each question, except maybe the first when I spent some time thinking about just how to do it at all, was either debugging or just searching for a better solution. So my competitive programming skills did allow me to find the solution to each question relatively quickly, it just wasn't smooth for all of them, especially the second one. So competitive programming is enough, even for LeetCode's hardest / most annoying questions. But even so, I said this last time too, if you're wondering what to do for yourself, just take the common sense approach. Practice what you're trying to get good at. If your sole goal is to get good at coding interviews, practice coding interviews. Don't waste time doing something else that's only like marginally related. But yeah, I'm starting to like this video format personally, and it's fun to do these even if I end up struggling on some of the questions. So if these keep doing well in the YouTube algorithm, I'll just keep making them, because why not? And if there are other websites that you want me to do the hardest questions of, feel free to comment these below. I might also consider doing the easiest questions just for fun if that does well. But yeah, that's about it. Hope you enjoyed. Hope this was helpful. Goodbye.